Hi, my name is Nicholas Koonsman, and today I'll be discussing with you a little bit about my senior project, which involves working with PetDoors.com to reduce the manufacturing learning curve. To start off, go over the agenda for this PowerPoint. First, we're going to go into the background, a little bit about PetDoors and what they do. Next, we're going to move into the problem statement, some of the objectives and goals, things that I wish to complete by the end of this project, some literature reviews that will give us some background knowledge as to some of the topics that we'll face, the design and methodology, and then lastly, the expected results and deliverables. So PetDoors.com is a small e-commerce business with around 15 employees. It's located in San Luis Obispo, and a lot of the employees are part-time college students. They manufacture and sell top-of-the-line pet doors, very high quality and not too cheap. And because of this, they have a low volume production with a medium amount of variation to account for some customization, but a main three product families. So for the problem statement, PetDoors.com serves to produce the highest quality pet doors on the market. Due to these high standards, quality is of the utmost importance, but this can be difficult due to the high complexity of the production process. Training new employees to meet these high standards and learn the complex process results in high learning curves and the throughput of lower quality products during the training cycle. So now we have the objectives. The two objectives that I have for this project are to reduce the learning curve and training time of new employees. As I mentioned before, a lot of the employees are part-time college students, and with that, you're going to have a high employee turnover rate as well as a lot of different employees coming in and out, not working too many hours. Next, I would like to reduce the overall product quality variation, as this is the first step in Six Sigma to increase quality standards. First you got to reduce the variation, and then from there you can move up or down the scale as to how much quality you want to put into your product. Meeting these objectives will make new employees more effective, reduce labor costs, and standardize quality of the throughput. To go into some of our literature reviews. So first one I looked into is a production quality control system is in action. This has to do with a Japanese company that introduced a system of standards that required production inspection and certification. Now, the reason this is important is because at each step during the process in the assembly line, there's someone that had to sign a certificate saying that the products being transferred to the next part of the line did meet all the standards. Now, while this may seem like kind of a waste in time, as inspections are a non-value added part of a production process, it does assign responsibility to someone and make sure that product quality standards are being met. So this means the product quality will increase, it will reduce quality variation, it must have an assembly line implementation, and the manufacturing process accounts for responsibility of someone to take action and figure out where exactly in the process things are going wrong. Next up is a method to determine optimal simulator training, examining performance improvement across the learning curve. Now, this had to do with a simulator, obviously, and some companies used VR or just watching videos. And it has to do with training time that is outside of the actual production cycle. So people that are putting things together, assembling them, whether it be mentally or through a video, VR, so that they can learn the process before they actually put their hands on the product. Now, the reason this is helpful is because when you have things such as the pet doors that are very high quality, you want to make sure that people that are actually building them know what the quality standards are and kind of how to do it, as this will take away from a lot of the mistakes and mishaps that can happen on a regular basis with new employees. Overall, trying to optimize the training time because you're not taking other workers out of the workforce in order to do this, some of your more experienced builders. Reduce training costs, increase starting performance index of new employees so they'll be more ready and effective right when they start, and increase the quality of the new employees' throughput. Next, we have using yield models to accelerate learning curve progress. Now, to improve the learning process by increasing quality control through the implementation of yield application models, these are some very high technical softwares that can be used in many large, high volume manufacturing processes where they want to account for defects. These processes are very expensive and have a large upfront cost to implement. but these track a lot of data, take pictures of everything that goes through them, and is able to figure out exactly where defects are occurring. It reduces the need for skilled labor because you have someone else checking or a software checking all of this. And it stores a lot of data, which can then be analyzed later on to make further improvements in the process and increase production speed, quality control, or other things that industrial engineers decide to look into with all this data. Now, for the design, I want to do a process improvement, which will incorporate a flow diagram, some line balancing, some inventory or work in progress analysis in the manufacturing facility, as well as develop a standard operating procedures. Next is the facility redesign. This will take into account 5S. I'll use tools like spaghetti charts, ergonomic considerations, and it'll help control inventory management. Now, lastly, for the expected results and deliverables, the new training process and procedure. This will be a step-by-step guide as to how new trainees should learn and what they should do in order to increase and maximize their effectiveness early on, reducing the learning curve. Next is a workbench redesign and standardization that will help when these new employees are transferring between different workbenches. Having them all be the same will reduce the time it takes for them to learn these processes, and they'll know where everything is no matter where they're working. Moving on is the manufacturing facility redesign. This will ideally introduce Kanban systems to minimize the work in progress, increase or decrease the travel time, as well as the lead times because they will spend less time walking around the workplace. And lastly is the storage design, which will help control materials handling so less products are damaged during the production process. Thank you.